Law of conservation of energy. Energy can be transformed from one form of energy to another form of energy. Energy can be transformed from one form of energy to another form of energy. In our day-to-day life, energy appears in different forms, such as solar energy, light energy, heat energy, chemical energy, wind energy, electrical energy, sound energy, muscular energy, mechanical energy, and so on. The sun is the ultimate source of energy that produces solar energy in the form of light and heat energy. Solar panels consist of a large number of solar cells and convert solar energy to the electrical energy. However, a solar water heater converts solar energy to heat energy. A plant also captures light energy from the sun to make food. Solar energy trapped by the plant enables them to change solar energy to chemical energy in the form of food. We also get wood from plants. Chemical energy stored in the form of wood can be transformed into heat and light energy. We know that the light energy enables us to see objects around us. A tube light is an example of light energy in which electrical energy is transformed to light energy. We also know that the heat energy causes an object to be hot. Heat energy can be produced by burning of fuels. Here, the chemical energy stored in fuels is transformed into heat energy. Some other sources of heat energy are the fossil fuels, such as coal and petroleum. They also store chemical energy. Chemicals in batteries or dry cells contain chemical energy. When a battery or a cell is connected to an electrical appliance, it transforms its chemical energy to electrical energy. Wind or moving air is also a source of energy. Windmills, when powered by the wind, produce energy. Windmills or wind turbines are connected to generators that convert mechanical energy of the wind to electrical energy. In a thermal power plant, coal is burned to produce heat energy which drives the electrical generator. In this way, heat energy is converted into electrical energy. This electrical energy can further be converted into heat energy or light energy. Sound energy is the energy generated by vibrations. Sound energy is not used for electrical power because the amount of energy that can be obtained from sound is quite small. But it is important to us as it enables us to communicate. Sound energy is also used to alert people, such as alarm of an ambulance. To lift a weightlifter uses muscular energy. However, the chemical energy trapped in our muscles is stored as muscular energy that enables us to do work. For opening a lid, we need mechanical energy. An object which possesses mechanical energy is able to do work. In the process of doing work, the object which is doing the work exchanges energy with the object upon which the work is done. When the work is done upon the object, that object gains energy, whereas the other object loses the energy. This gain or loss in energy by the objects is known as mechanical energy. In general, mechanical energy is the energy possessed by an object due to its motion, its position, or its shape, such as when an object is in motion. It has kinetic energy that is also known as energy of motion. For example, a moving car or a flying bird. When an object is at some position, it has potential energy that is also known as energy of position. For example, water at the top of a waterfall or stored water in a dam. Many forms of kinetic energy. For example, vibrational kinetic energy, rotational kinetic energy, and translational kinetic energy. Translational kinetic energy of a body of mass m moving with velocity v can be measured as half of mv square. If the kinetic energy increases, the object moves faster. The energy stored due to the vertical position is called gravitational potential energy, and the energy stored in elastic materials is called elastic potential energy. Gravitational potential energy of a body of mass m at a height of h from the ground is equal to mgh. The higher an object is from the ground, the bigger is its potential energy. Both potential energy and kinetic energy can be interconverted. For example, water is stored in a reservoir at a great height, possesses high potential energy. At the time of water supply, water rushes downwards with a great speed and easily reaches to the different parts of the city, and thereby potential energy is converted into kinetic energy. A body may have potential energy as well as kinetic energy at the same time, and the sum of potential energy and kinetic energy possessed by system remains constant at all times. The sum of both energies is called mechanical energy. A simple example of the transformation of kinetic energy into potential energy and of potential energy back into kinetic energy is a simple pendulum. When we give a push to the bob, it possesses kinetic energy, and as it reaches to its maximum height, its kinetic energy completely converts into potential energy. Energy of the swinging pendulum can be either potential or kinetic, or a mixture of potential and kinetic, but its total energy at any instant remains the same. Another example of such type of transformation of energy is the motion of a car on an inclined plane. When the car is at the peak of an inclined plane, it possesses only potential energy. When it moves downwards, its potential energy converts into kinetic energy. When the car moves on horizontal surface, it possesses kinetic energy only. Throughout its motion, there is a transformation of gravitational potential and kinetic energies, but again at any instant its total energy remains the same. In a dam, stored water possesses potential energy, and when the water falls, it attains kinetic energy. A water wheel is used for converting the energy of moving or falling water into rotational kinetic energy, and the rotating wheels help to produce electricity in the generators. Thus, energy of the running water passes from water to the wheels and ultimately gets converted into electricity. The water that turns the generator wheel loses energy and the generator wheel gains energy. The sum of the energies of the system remains constant. In this activity, a brick is hanged at a height which possesses potential energy. For a hypothetical frictionless condition, when we drop the brick, its potential energy decreases to zero and kinetic energy increases to its maximum value, or in other words, its potential energy converts into kinetic energy. At every point, total energy remains the same. During the motion, the brick possesses both potential and kinetic energies. But if there is air, then some internal energy of the brick is also produced. In this condition, as we drop the brick, its potential energy decreases. Initially, its kinetic energy as well as internal energy increases, but finally its kinetic energy decreases and internal energy increases. In this case also, the total energy remains the same. This activity shows that energy can neither be created nor be destroyed. It can only be transformed from one form to another. This condition is referred to as law of conservation of energy. Let's relook the activity. Let the mass of the brick be m, and initially it is at height h. At that point, it has no kinetic energy, but it has potential energy equal to mgh, and thereby the total energy at point A comes out to be mgh. After falling a distance of x, it reaches point B, where it has kinetic energy equal to half mv square and potential energy equal to mg multiplied by h minus x. Using the second equation of motion, the velocity of the brick at point B comes out to be under root 2gx, and thereby the total energy at point B also comes out to be mgh. Similarly, at the ground, its total energy again comes out as mgh. This shows that it is clear that potential energy of the body continuously decreases as the body falls, whereas its kinetic energy continuously increases as it comes closer to the ground. That is, potential energy is transformed into kinetic energy. Similarly, if we throw a ball in an upward direction, kinetic energy of the body continuously decreases and its potential energy continuously increases. That is, its kinetic energy is transformed into potential energy. Here also, total energy of the ball remains constant throughout the motion. Let's see an example. A rocket of mass 2.5 multiplied by 10 to power 6 kilogram takes off from a launching pad and acquires a vertical velocity of 1 kilometer per second at an altitude of 30 kilometers. Calculate the total energy of the rocket. First of all, let us convert all the values in SI units. Kinetic energy of the rocket at the altitude of 30 kilometers comes out as 1.25 multiplied by 10 to the power of 12 joules. And the potential energy comes out as 0.75 into 10 to the power 12 joules. Therefore, the total energy, that is the sum of kinetic and potential energy, comes out to be 2 multiplied by 10 to the power 12 joules. Let's see another example in which a ball dropped from a height h. When it reaches the ground, its velocity is 50 meters per second. Let's calculate the height h. When the ball reaches the ground, the potential energy of the ball is converted into kinetic energy. By equating the two energies, the initial height of the ball comes out as 125 meters.